Greetings. In this one, I'll be talking about the cycle notation of permutations, and I will not be talking about permutations again, what they mean, because that's like a requirement to know first before going to perhaps the cycle notation. Well, basically we have an input set. Here we see finite discrete set of numbers, and then there's outputs, and they are the way that in the first row we have inputs, in the second row we have outputs. 1 goes to 3, 2 goes to 5, 3 goes to 1, so on. We can write it using cycle notation, which I would also almost expect to be known first, maybe, before going to the point of multiplying cycles that are not disjoint, which is the main point of this one that we'll be focusing on. But anyway, I can do a revision of that, how to write cycles out of a permutation, how to represent a permutation in this one-line cycle notation. Basically, I can start with any number, and I will follow the permutations information. So I'll choose any number in the inputs, and of course the outputs have the same numbers, but I'm looking at the inputs. Let's choose 1, and then I see where it goes. It goes to a 3. And the way I read a cycle is, I have this beginning of parentheses, then I go to the right. When I reach the last number in that cycle, I go back left to the first one. That's the order in which I read it. So 1 goes to 3, 3 will go back to 1. Therefore, I close the cycle because 3 goes to 1, that information is there. That's where I am. That's where the loop starts. It will just go in this loop. So I will now end this cycle and begin with another number outside of this cycle. So now it's 2, and that goes to 5. So I write that. 5 goes back to 2, so I again have to end the cycle. Then what's left? The order of how I represent the numbers for different cycles doesn't matter. I can switch the order of the cycles. The information will be the same to recreate this permutation if I want to write it out of this information of cycle notation. So what number have we not covered yet? That's 4. And 4 goes according to this permutation to 6. And 6 will go back to 4, so I can close it because it's read from the left to the right, then going back. So that's the idea. But now the main point of the video. The main point is to look at an example where we have cycles, but they do not represent a permutation or one permutation itself, but sort of a multiplication of more information, more permutations, because there's numbers that are repeated. Here we see these cycles are so-called disjoint. Also, by the way, they all have 2 numbers. That's not a rule. Cycles can have more numbers. So these are called 2 cycles because they all have 2 numbers. 2 cycles are also called transpositions. That's just a term. But now let's look at this example. This is the main point of the video, where we want to multiply cycles, so multiply, which means, as we saw, a permutation will generate cycles, but they will be disjoint in the way that they will not share numbers. There will be no shared numbers among the parentheses. If some numbers are in one parenthesis, they will not be contained in the rest. We see that 1, 3 is not in the other 2, and that goes for the other parentheses as well. But here we see that. Here we see 1, 2, 3, 4, and 3, 1 in the second parenthesis, where both 3 and 1 are shared with the first parenthesis. So we can sort of multiply these 2 cycles. Also, we see the cycle has 4 numbers instead of 2 that we saw before, but of course, cycle can have any number of numbers. It depends on the case. So here we see 3 and 1 are contained in both cycles. So if we multiply these cycles, so-called, what we will generate is a new way of writing this information. Once we multiply them, we write it as disjoint cycles, so that we can then quickly write it as a permutation. Now this cannot be written as a single permutation yet, because more numbers are shared among the parentheses. We want to sort of multiply the cycles and write it in a similar form, not necessarily 2 cycles, but in such a way that outside that parentheses, the same number that was inside that one parentheses, so outside the cycle, the number will not be repeated in some other cycle next to it. So how do we go? Again, I can start with a 1, similarly like when we were doing it from a permutation towards a cycle before. So let's say pick a 1, and then I'm multiplying in the way that we go from the right to the left. The information in the cycle on the right, and the multiplication is primary. So even though I chose a 1 from the left cycle, I will first refer to the right cycle in case there is the same number in the right cycle as well. And in the case of 1, it is. I choose a 1, but I first look, is there a 1 in the right cycle? There is. And according to the cycle, a 1, because of the direction of reading the cycle, when we reach the last one, we go back to the first one. Because there's a 1 in the left cycle, I refer, and I see it also in the right cycle, I first refer to the information in the right cycle, and that is, it goes to 3. And then 3 I then take, and look what the first cycle said about it. 3 goes to 4. So only that I write. So because 1 was also contained in the right cycle, I first see, oh, according to the right one, it goes to 3. But then I carry the information to the first cycle and see where that goes from the 3. And that 4 is the result. So now 1 goes to 4. Although this cycle would just say 1 goes to 2. But I first have to refer to the information in the right cycle as long as the same number is contained there as well. Now we go for 4. 4 goes to 1. And 4 was not contained according to the first cycle. 4 was not contained in the right cycle, so I can just take the information of the left cycle. And because it went back to 1, I can close the cycle according to the logic or the algorithm of writing down cycles. And then let's take another number from this left parentheses to start another cycle. So now we have a 2 and I check, is a 2 in the right cycle? There is no 2 in the right cycle, so again I can proceed and just write what the left cycle tells us. So 2 goes to 3 according to the left one. Now 3, is there 3 in the right cycle? Yeah, there is. So I first have to take that information. According to the right one, 3 goes to 1. So I take that 1 and use it in the first one now. 1 goes to 2. So I'm back at 2, I have to close it again. And I've covered all numbers in these 2 cycles. So now we've completed, we got 2 disjoint cycles out of 2 non-disjoint cycles. And now I can simply quickly write it as a permutation as well. So according to this information, 1 will go to 4, but also 4 goes to 1 according to the cycle, and 2, 3, and 3 to 2. So we can now write it as a single permutation.